Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project: 3D printing gigantic objects using a Python-powered jigsaw generator. It's all about automating the process of splitting large 3D models into smaller, printable parts. Exciting stuff!
Absolutely. I saw the article. The sheer scale of this is impressive. So how does this jigsaw generator actually work? Is it all about slicing the model into pieces?
Not just slicing, it's more sophisticated than that. The core is a clever dovetail joint design, created using OpenSCAD. Think of it as a series of interlocking puzzle pieces, but with a tapered design for extra strength and a self-aligning feature. The author meticulously details the geometry generation, step by step, from a simple square tooth to a complex, tapered, interlocking design. It's a beautiful piece of generative design.
A tapered dovetail. That's smart. So it's not just simple cuts, but carefully designed interlocking shapes. But how does it handle the actual splitting of a large model? Does it work directly on the STL file?
That's where the Python script comes in. It takes the STL, finds the bounding box, rotates it to optimize for the printer bed, and then calculates how many subdivisions are needed to fit the pieces onto the bed, accounting for the dovetail joint size. Then, it uses an OpenSCAD template to generate the STLs with the dovetail joints already incorporated, ready for slicing and printing.
Clever. So it's a two-stage process. OpenSCAD for the geometry, Python for the splitting and nesting. But the article mentions some performance challenges, right? Something about CGAL?
Exactly. Initially, the OpenSCAD process using the CGAL library was incredibly slow. 4 hours per operation. The author encountered errors due to non-manifold meshes, but then, a breakthrough. They switched to OpenSCAD's new manifold backend, resulting in a 64,500x speed improvement. From 4 hours to 223 milliseconds. That's a game changer.
Wow, that's an incredible speed up. A testament to the power of the new geometry library. So, what were the final results? Did it actually work for printing large objects?
Yes. The author successfully printed a large speaker system, originally designed for a much larger printer, on a standard Prusa i3. The images show the individual parts, neatly nested and ready for assembly. The dovetail joints seem to work perfectly, and the nesting algorithm cleverly places the parts to minimize the number of print beds needed. It's a really impressive outcome.
Amazing! But there were some minor issues, right? Something about thin teeth and potential print problems?
Yes, there are some areas for improvement. The author notes that very thin teeth in the corners could cause issues. They suggest skipping teeth in certain areas to avoid problems. Also, there's the potential for Z-fighting, but it seems manageable. Overall, though, it's a remarkably successful project.
Definitely. This is a fantastic example of combining CAD, generative design, and scripting to overcome limitations in 3D printing. It opens up possibilities for creating much larger objects than previously possible with smaller printers. A truly inspiring project.
Absolutely. And the code is available too. It's a great resource for anyone interested in exploring similar techniques. This project showcases the power of automation and clever design in additive manufacturing. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of giant 3D printing. Have a great day.
Bye-bye.